Hello, 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 hello. Let me check the voice, guys. Wait a minute. Hello. Okay, everything is good. Yeah, we can start. Okay. So, good evening, all of you. Today we are going to discuss JEE Advanced PYQs on moving charge and magnetism. Okay. पहले कुछ questions we have discussed some questions in the last class. Okay. We have discussed I think 5 questions, right? Some questions are left. Now we're gonna discuss remaining questions. Okay. बचे हुए क्वेश्चंस को भी डिस्कस करते हैं। ठीक है, स्टार्ट करते हैं। पिछले क्लास से कोई डाउट हो तो बता दीजिए। ठीक है, चलो स्टार्ट करते हैं। ओके, हियर इज आवर फर्स्ट क्वेश्चन, मींस सिक्स्थ क्वेश्चन। A cylindrical cavity of diameter A exists inside a cylinder of diameter 2A as shown in the figure. Both the cylinder and the cavity are infinitely long. A uniform current density J flow through the length. If the magnitude of the magnetic field at the point P is given by, means that is B at P is equal to n by 12 times of mu naught AJ, that is AJ, right? Hello, hello. Okay, hello, hello, hello. Okay. So the magnitude of magnetic field is mu, that is given to us, that is NV12 of times of mu naught AJ. Okay, we have to return the value of n, that is capital N. Okay. So there is an infinite long cylinder of diameter 2A, and there is a cavity, that is this one. Okay, of diameter A. Now we have to find the magnetic field at point P, right? Do you understand this? So then B at point P means resultant, that is resultant magnetic field at point P is equal to, one is due to this whole cylinder, infinite long cylinder, that is B due to cylinder minus B due to cavity. If I, that is I told, that is due to cylinder, I told it as total, and this as due to cavity. Okay, first we find the magnetic we apply reduced mass concept here. Okay, as we do in the reduced mass, same thing we do here. एक बार अपन एज्यूम करेंगे कि पूरा करंट, पूरे के थ्रू करंट जा रहा है इन सेम डायरेक्शन. सपोज द करंट थ्रू द this this cylinder is in the dot direction. One time we assume that the current through the cavity in the dot direction, and we in the other case we assume that in the cross direction. Okay, then both nullify each other. Okay, सेम चीज अपन रिड्यूस मास कॉन्सेप्ट में करते थे, एक बार उसको पॉजिटिव ले लेते थे, एक बार उसको नेगेटिव ले लेते थे, राइट? सेम चीज करते थे। तो अपन जब पॉजिटिव लिया है तो पूरे एक बार तो पूरे टोटल से निकाल लेंगे और एक बार ओनली कैविटी से निकाल लेंगे मैग्नेटिक फील्ड एट बी, राइट? ये समझ में आया? दैट इज b due to t is equal to mu naught I through the total upon 2 pi r, right? That is due to a infinite long wire. That is vt is equal to mu naught I total is equal to pi r square into density, that is area into density, it is total current into 2 pi r. You understand this? R cancel out each other and we get mu naught pi r, pi also cancel out each other, that is we get mu naught j r upon 2 b total at point p. Okay, b total at point p and b due to cavity at point p. From here we get b total at point p is equal to mu naught j a by 2. Do you understand this? Do you understand this? Do you understand this? Okay. Now b find b due to cavity, that is mu naught I through the cavity upon 2 pi distance from the cavity, right? That is equal to mu naught I into area of cavity, that is pi a square upon 4 into j upon 2 pi. What is the distance of the point P from the center of the cavity? That is, this is a by 2 and this is a. That is total distance is equal to from here to here is 3 ab 2, right? That is 3ab 2. From here we get BC is equal to mu naught pi a square j upon 12 pi a, I think. 2 to cancel out this and this will become okay. I think it's correct and we get mu naught a j upon 12, right? Now move to the next page. Okay, move to the next page. What we get? B due to cavity is equal to mu naught aj upon 12 and B total is equal to mu naught aj by 2. From here we get B remaining, that net at point B is equal to mu naught aj by 2 into minus mu naught aj by 12, right? From here we get 5b 12 times of mu naught aj, right? B resultant, B at R point P net. Okay, so what is our value of n? That is value of our n is 5. Okay, so value of n is equal to 5. Do you understand this? Just you have to identify this concept, that reduced mass concept. Okay, once you calculate by the total taking a whole as the system and once by only the cavity in the negative direction, right? If you take the current through the diameter through the cylinder as dot, then once calculated by dot and then do by the cross direction. Okay, and subtract it from the total. Do you understand this? As we find the mass in the mechanics. Okay, okay. Do you understand this? Now move to the next question. Seventh. Do you have any doubt? Any doubt? Okay. Move to the next question, that is a long circular tube of length 10 meter and radius 0.3 meter carries a current I along its curved surface. Okay. So there is a small wire of loop resistance 0.005 ohm, that is resistance of this small loop is 0.005 ohm and of radius zero point 0.1 meter, and radius of this is zero point 0.1 meter, is placed inside the tube with its axis coincide with the axis of the tube. Okay, both are the axis of both are same, means okay. The current varies as I is equal to I naught cos 300 t, where I naught is constant. If the magnetic moment of the loop is n times of mu naught I naught sin 300 t, then value of n. Okay. So the current is flowing in the on the lateral surface. Okay, on the curved surface of a cylinder, like in this direction. Okay, like this as a solenoid. If you want to assume it as a solenoid, right? Current is going in this direction, like this. Okay, like this. Okay, do you understand this? And a small uh, loop is placed at the axis at the center of the cylinder, right? Do you understand the condition? That is height of our cylinder, that is this is 10 meter, and the radius means that is diameter is 0.6 meter. There is a current I along its curved surface. Okay, so a wire of loop resistance, that is resistance is equal to 0.005 ohm, and radius, that is small r, is equal to zero point 0.1 meter, right? Okay, so first we have to find the magnetic moment of the loop is okay. We have to find the magnetic momentum. Okay, any doubt in the last question? Then I move going to solve this. Okay, right. That is, if I want to find the flux, that is our magnetic momentum M is equal to current into area, that is I into A, I dot A, right? To understand this magnetic momentum, I dot A, magnetic momentum. Okay, so first we have to find the current through this small loop. Okay, for that we have to find the change in the magnetic flux, that is flux, that is equal to B dot A. Do you understand this? That is flux is equal to B into pi small r square. Okay, B into pi small r square. From here we get, first we have to find V. If we consider this as a solenoid of total turn, number of turns is 1, because it is a single, okay, not divided into n small parts or something like that. It is whole complete n, that is number of turns is equal to 1, and we can consider it as a solenoid, and the B is equal to mu naught small n, sorry, capital N I by L, right? Here is capital N is equal to 1, that is V is equal to mu naught I by L, right? To understand this, as it is completely a whole single wire, we can consider it as a whole single wire, right? Or you can go through the integration. Okay, this is simple method to understand this. Okay, don't make it more complicated. Okay, keep it simple. From here we get flux is equal to mu naught I by L into B pi r square, that is flux through the small ring placed at the center. Do you understand this? To understand this, and what is the value of I? That is phi is equal to mu naught upon L I naught into pi r square into cos 300 t. To understand this, from here we get, that is voltage developed in the loop, that is epsilon EMF, that is minus d phi by dt. from here we get d5 by dt as minus of please move to the next page. Let me solve this on the next page. Okay, from here we get sorry, epsilon is equal to minus d5 by dt, that is equal to differentiation of m- mu naught I naught by L into pi r square cos 300 t. Okay, you understand this? Mu naught I naught by L pi r square cos 300 t. Okay. On differentiating, we get mu naught I naught by t into pi r square. What is the differentiation of cos? That is minus sign, and minus minus cancel out each other. That is sine 300 t into 300, right? From here we get 300 times of mu naught I naught upon L. Sorry, this one is L, okay? By L into pi r square sine 300 t. We get epsilon, okay? From here we get I, that is current generated in the loop, is equal to epsilon upon R, that is resistance, that is 300 into mu naught I naught upon L into R pi r square sine 300 t. Okay, we get the I. What is the what is our magnetic momentum? That is I into A. That is I into A. Wait a minute, guys. Okay. So what is our of that is magnetic momentum? Magnetic momentum, that is I dot A. From here we get, okay. From here we get our magnetic momentum as I dot A, that is equal to, what is our I? That is 300 mu naught I naught upon L R pi r square sine 300 t, right? What is A? That is pi r square. Do you understand this? Okay. Now put the value, that is magnetic momentum is equal to, if we write it in the terms of, means we need to write it in the terms of, I think, okay, mu n times mu naught I naught, okay, and sine, okay, we have to keep mu naught I naught sine 300 times of ts side, okay, that is mu naught, wait a minute, guys, okay, mu naught I naught sine 300 times of t. We keep it as here, and what we get in the side, that is 300 times of r pi r square whole square upon lr. So this is our value of n, right? If I keep mu naught I naught and sine 38 out, okay, so we get this value, that is 300 times of pi r square ka whole square upon lr. Okay, let me calculate this. Okay, so from here we get n is equal to 300 times of mu naught, sorry, mu naught no, pi r square a whole square upon lr, right? From here that is 300 times of pi square, that is r raised to power 4 upon, that is L into R, right? if you calculate this whole thing, I think you should calculate it. It's, I think, comes out to be 6, right? That is, let me calculate this. 300. What is pi? That is 3.14 a whole square into what is r? That is resistance. That is zero point 0.1, I think. Oh, sorry, radius. Okay, 4 upon what is L? That is 10. What is resistance? That is 0.005, right? Okay. Do you understand this? After calculation, we get, I think, 0.005, right? If you 10 raised to power 4, if you that is 10 raised to power 4, this will get 10 times and this will cancel out this. Okay. We get 3 into 3.14 into 3.14 upon 5. So I think if you find the nearest integer, it will be 6. Okay. Nearest integer. Okay. Nearest integer में ही return करना पड़ेगा अपन को. Okay. Let me calculate this. Please wait, guys. Okay. So it's I think come out to be 5.9. Okay. 5.9 something. Okay. Approximately 5.9. So it is written in the integer form, that is n is equal to 6. Okay. Nearest integer में इसको return करना. Okay. So n is equal to 6. Do you understand this? Now move to the next question. Any doubt from this question? Do you have any doubt from this question? Let me know. कोई doubt है क्या? Any doubt? Okay. Move to the next question. That is our eighth question. Okay. If you have any doubt, please tell me. I will tell you. So let's move to the next question. A steady current I goes through a wire loop PQR having shape of right angle triangle. Okay. With PQ as 3, PR is equal to 4x. Okay, there is also 1x, okay, 3x, 4x, and 5x QR. Okay, and the magnitude of magnetic field at P due to this loop is k times of mu naught I upon 48 pi x. Okay, find the value of k. Okay, okay. So what is the situation? That is, here is our right angle triangle with P as P here, PQ, and this is R. That is, PQ is equal to 3x, right? PR is equal to 4x and QR is equal to 5x. Okay. So here is our, okay, here are the dimensions. Okay. The magnetic field at point P due to this loop. Okay, we have to find the magnetic field at point P. It is B at P. Okay. We have to find this and the current is going in the loop like this. Okay, कौन सा भी डायरेक्शन ले लो आप, वो तो सेम रहेगा. ओके, बस डायरेक्शन चेंज होगा एट पॉइंट पी पे. तो देखो, as in the pathway P is in the pathway of PQ and PR, so the magnetic field, that is magnetic field is P due to PQ is equal to 0, as well as due to B at P due to PR also 0, right? इन दोनों की वजह से तो 0 हो जाएगा, इन दोनों की वजह से. Only the magnetic field is due to the QR, right? So if we take here as let it be the O dash, okay, or O. Simply write O, okay. So this, suppose this angle is theta 1 and this angle is theta 2, right? So what is the magnetic field due to a wire at a point P at a distance D? First we have to find the distance D, and then we have to find the, that is, if I calculate this, if this one is theta 1, that this one is theta 90 minus theta 1, that is theta 2, right? Do you understand this? As theta 1 plus theta 2 is equal to 90, okay, and this is equal to, this angle is equal to 90 minus theta 1, as this angle is equal to 90 degree, right? If I, if this angle is 90 degrees, then this is 90 minus theta 1, that is equal to 90 minus theta 1 is equal to theta 2, and this is equal to theta 1, right? If you remember, I will tell you, okay, wait a minute, that is Q and this is R. If we want to find magnetic field at a distance D due to a finite wire, then the angle we measure from the point, right? That is, this one is theta 2 and this one is theta 1, right? We angle and this distance is D. Like this is the whole scenario, right? And the current through this is I. Do you understand this? Do you understand this? So, what is the formula of magnetic field due to the finite wire at a distance D? That is equal to mu naught I upon 4 pi D, that is the distance from the wire, into sine phi 1 plus sine phi 2, right? That is B at P, magnetic field at P. From here we get B at P is equal to mu naught I upon 4 pi D into, what is sine theta 1? That is equal to this side, if I see this side theta 2, that is equal to theta 2 sine theta 2, sorry, sine theta 1, sine, if I apply sine theta 1, that is 4x upon 5, 4x upon 5x, plus sine theta 2 is equal to 3x upon 5x. From here we get, B at P is equal to mu naught I upon 4 pi D into 7 upon 5, right? Do you understand this? Do you understand this? Now we have to find the, okay. Do you understand this? That is BP is equal to, comes out to be 7 by 5 times of mu naught I by 4 pi D. And what is the distance? That is D is equal to, D is equal to, if I see the D, that is this distance, this is equal to, if I apply cos theta 2, that is, okay, if I find this distance, that is equal to, if I apply cos theta 2 is equal to d by 3x, from here I get d is equal to 3x times of cos theta 2, right? Do you understand this? Do you understand this? Now put the value of this in the equation, then we get, that is, small d is equal to 3x times of cos theta 2, I think. What is theta 2? What is theta 2? Cos theta 2, okay. What is theta 2? That is 3 by 5, right? That is 3 by 5. That is equal to, d is equal to, 3x into 3 by 5. I think it's correct. Please once check the calculation error. Okay. Please once check the calculation error. From here I get 9x upon 5. Is it correct? Please check the calculation. I think it's 4x, right? Am I do something wrong? I need this as the theta. Then this is equal to, this is cos theta 2 and this is sine 30 sine theta 2, right? So this is has to cos theta 2. Okay, cos theta. Okay, 4 by 5, right? Now that's why I'm, that is 4 by 5, right. I do the wrong. Okay, that's why I'm get confused. That is 4 by 5, right? So it is 12x by 5, right? That's why I confused. Okay, so from here we get BP is equal to 7 by 5 times of mu naught I upon 4 pi into 12x upon 5. 5 cancel out this, we get 7 times of mu naught I upon, that is 48 times of pi x. From here we get 7 times of mu naught I upon 48 times of pi x. Okay, from here we get value of n is equal to 7, right? Or value of k, sorry, that is 7, not n, that is k. Do you understand this? Okay, wait a minute guys, wait a minute. Okay, hello, hello, do you understand the question? Any doubt from this question? Hello, hello, कोई डाउट? नॉलेज हब, कोई डाउट है क्या? Now move to the next question. If you have any doubt, then tell me, or I'm going to move to the next question. Okay, no doubt. Okay, let me move to the next question. Okay, this one. Please once read this question. I will check the live class. Okay, let me check the live class. Okay. Okay. So there is no doubt. We can start. Okay, this is our next question. A thin, stiff, insulated metal wire. Okay, means these are insulated. Okay, a thin strips into a metal wire is bent into a circular loop with its two ends extended tangentially from the same point of the loop. Okay, the wire loop has mass m. Okay, this has mass m and radius r. Okay, radius r है and it is in the uniform vertical magnetic field B naught. Okay, यहाँ पर एक magnetic field है in the upward direction. Okay, as shown in the figure. Initially, it hangs vertically downward because of the acceleration due to gravity G on to conducting on to non-conducting support PQ. Okay, conducting. Okay, AB conducting है, right? P and Q. When a current I is passed through the loop. Okay, when the current is passed through this loop, the loop turn about the PQ by an angle theta given by ओके, अपन को जब ऐसे करंट पास कर रहे हैं, अपन इससे लूप से करंट पास हो रहा है, तो एक पी क्यू के अबाउट, दैट इज ये जो रॉड है, इफ आई वांट टू शो यू, लेट मी दिस, ओके, जो अपना रॉड है ऐसे उसके अबाउट ऐसे ऐसे इस तरह से लटका हुआ है, ऐसे देखिए हॉरिजॉन्टली ऐसे घूम जा रहा है, ठीक है। ये पी क्यू जो अपनी रॉड है उसके अबाउट ऐसे घूम जा रहा है ऊपर की साइड, समझ में आ रहा है, ऐसे घूम जा रहा है, ठीक है। थोड़ा 3D में विजुअलाइज करने की कोशिश करें प्लीज, अंडरस्टैंड द क्वेश्चन, आफ्टर दैट आई विल टेल यू द प्रोसीजर हाउ टू सॉल्व दिस, ओके। जब ऐसे टिल्ट होगा एक साइड मीन्स लाइक दिस इज द पी क्यू, ओके, इन द डॉट मीन्स ऐसे मैं पी क्यू के परपेंडिकुलर देख रहा हूँ, मीन्स इन द पैरेलल टू द डायरेक्शन ऑफ पी क्यू, ओके। तो इस साइड से कैसे होगा, ऐसे टिल्ट हो जाएगा, राइट, ऐसे टिल्ट हो जाएगा एट एन एंगल थीटा फ्रॉम द वर्टिकल, ओके, वर्टिकल से थीटा डिग्री एंगल पे टिल्ट हो जाएगा। यू अंडरस्टैंड दिस। और जब ये टिल्ट होगा तो उस केस में क्या होगा, टॉर्क जो नेट टॉर्क होगा वो क्या होगा, जीरो, ओके। तो एक तो इस पर टॉर्क लग रहा होगा ड्यू टू मैग्नेटिक फील्ड, ओके। एक टॉर्क लग रहा होगा डाउनवर्ड, दैट इज टॉर्क ड्यू टू ग्रेविटी, राइट, दैट इज टॉर्क ड्यू टू ग्रेविटी should equal to torque due to magnetic field, understand, for the stable condition, ओके। जब तो नेट टॉर्क जीरो होगा इस पे, ये समझ में आया, डू अंडरस्टैंड दिस, डू अंडरस्टैंड दिस। सो this is the angle theta, right, and here is the magnetic momentum in this direction. So what is the torque due to magnetic field, torque due to magnetic field, that is m cross b, right, torque due to, do you understand this, do you understand this, that is equal to, if you see about this magnetic field in this direction, that is in the b cap, and magnetic momentum in this direction, okay. So if this is theta, then this is theta, and this is equal to 90 minus theta, that is angle between m and v, that is m b sin 90 minus theta, okay. And the torque due to gravity is equal to that is mass. If we see this distance, this is r cos theta, and this perpendicular distance is r sin theta, okay, that is m g r sin theta. Do you understand this, please। हमने दोनों की वजह से टॉर्क लिख लिया है, ठीक है। फ्रॉम हेयर इफ यू सी like this, from this point, okay, m in this direction, okay, if I say this angle as theta and the magnetic field is in this direction, okay, let me show you, that is in this direction, b in this direction, if this is theta then this is also theta, if this is theta then this is 90 minus theta, right, and the gravitational torque is in this direction, torque due to gravity, okay, that is equal to, and if we see this angle as, if this is theta then this is also theta, right, and this distance is equal to r sin theta. From here we get mg r sin theta is equal to mb sin 90 minus theta. From here we get mg r sin theta is equal to mb cos theta. From here we get tan theta is equal to mb upon mgr, okay. We get the value of tan theta, that is mb upon mgr, right. So this is our value of tan theta. And what is the value of m and b? Just put the value of m and b, that is I into pi r square, right? That is pi r square, and that is b naught upon mg r. R cancel out is this, we get I pi r v naught upon mg. So tan theta is equal to I pi r, because the option in this form, right? Okay. So which one is our answer? That is first, I think, right? First one is our answer. Okay. Any doubt in this question? Any doubt? हेलो भैया, साइंटिफिक टीजर, हाँ बोलो, कोई डाउट? ओके, कोई डाउट नहीं है ना? चलो नेक्स्ट क्वेश्चन पर मूव करते हैं। कोई डाउट हो तो बताओ। ओके, मूव टू द नेक्स्ट क्वेश्चन, दैट इज 10th. ओके, so an infinite long wire located on the z-axis, okay, carries a current I along the plus z direction. Okay, so here our Cartesian plane, okay, that is z plus z, this is x and this is y, right? X y z, x y z, right? So this is our plane. An infinite long wire located on the z axis, okay, the current is in this direction along z plus z direction and produce the magnetic field, that is b cap. B, okay, b, the magnitude of the line integral along the line from the point this, okay, means there is a point, okay, x y z, x y direction, that is, what is x, that is minus 3 k, and what is a, that is in this direction. Okay, so means from this light, this is our, so z is equal to 0, right now? So this is x. So if I see from the front, let me change the view. Okay, like this one is our y, sorry, z. Okay, this one our z, and this one is our y, and this one is our x, right? In the front, right? So as it in the z direction, so it is in the positive, right? So it is like this, from minus root 3a comma 0 to in the a comma 0, right? Do you understand this? Do you understand this? That is this case, and this is the value of a. Do you understand this? This is theta 1 and this is theta 2, and this is the current carrying wire in the z cap, right? Do you understand this 3D? This 3D graph? Okay, this is negative z direction. Okay, that is in the back. So we have to find the line integral. If I take a small distance, suppose if I take a small d theta angle, right? That is, if I zoom it, okay, if I take it as a small angle d theta, okay, what is this distance? That is this, that is equal to r d theta. So this is equal to r d theta. right? If I like at a distance r from the center, okay, this is d theta, okay. So what is this distance? This is r d theta. So I take similarly a small element that is r d theta from at a distance r from the center, right? So that is our small dl element is equal to r d theta. That is the magnitude of our small element on what is that is b is equal to mu naught I upon 2 pi r. Now, okay. So what is v dot dl? That is equal to, let me move to the next page. समझ में आया ये? That is b vector, that is our b dot dl, integral of b dot dl is equal to, what is our b? That is equal to mu naught I upon 2 pi r into r into d theta. If we integrate it from, okay, what is the limit of integration? That is, if I tell you, the limit is from theta 1 to theta 2, right? Minus theta 1 to plus theta 2, right? Do you understand? Do you understand this? Do you understand this? That is equal to integration from minus theta 1 to plus theta 2 is equal to mu naught I upon 2 pi d theta. From here we get mu naught I upon 2 pi. What is d theta? That is d theta 2 minus of minus theta 1, right? From here we get mu naught I upon 2 pi into theta 1 plus theta 2, right? We get the value of, we have to find the theta 1 and theta 2, right? If you see the image, let me move to the next page, right? Sorry. Okay. So here is our minus a root 3 comma a, and it is our a comma 0, right? So it is like this, right? Okay. And this is our theta 1 and this is our theta 2, right? That is theta 1, that is tan theta 1 is equal to, what is this distance? That is this distance from the origin, that is a root 3. A root 3 upon what is this distance from origin, that is 0. Oh, a, sorry, that is theta. From here we get theta 1 is equal to pi by 3, I think. Okay. Okay. What is theta 2? And what is theta 2? That is tan theta 2 is equal to this distance. This is equal to a. And what is this? This is root 3 times of a. And this is also a. Right? So tan theta 2 is equal to a b a. That is equal to 1. From here we get theta 2 is equal to pi b4. So from here we get our b dot dl is equal to mu naught I upon 2 pi times of pi by 3 plus pi by 4. We get 7 pi by 12, I think, right? Or mu naught I upon 2 pi, right? Pi cancel out each other and we get b dot dl is equal to 7 times of mu naught I upon 24, right? So our b dot dl is equal to 7 by 24 times of mu naught I, right? Do you understand this? Any doubt in this question? Any doubt? Pulkit, any doubt? हेलो पुलकित, कोई डाउट है क्या इस क्वेश्चन में? Hello, Pulkit. Now, if you understand this question, then I move to the next question, right? Understand this? Now, let me move to the next question. That is this one. एक क्वेश्चन है, करंट टेंसर है या स्केलर? ओके, स्केलर क्वांटिटी है। ओके, अभी आप टेंसर, आप जब बैचलर्स में जाएंगे जब पढ़ेंगे उनके बारे में। ओके, अभी आप इस लेवल पे इतना ही देखिए कि करंट स्केलर क्वांटिटी। ओके, जो अपन डीएल एलिमेंट लेते हैं दैट इज इन द डायरेक्शन ऑफ करंट, राइट? अगर अपन ऐसे आई लेते हैं, उसके डायरेक्शन में जो डीएल स्मॉल एलिमेंट लेते हैं उसकी वजह से, डीएल डायरेक्शन में लेते हैं ना डीएल, उसकी वजह से वो वेक्टर क्वांटिटी बनती है, दैट इज आई डॉट डीएल करके जो बनता है। ओके, और डीएल क्या होता है? वो एज अ वेक्टर क्वांटिटी रिप्रेजेंट करता है करंट के डायरेक्शन को, राइट? ओके, करंट इटसेल्फ इज अ स्केलर क्वांटिटी। ओके, टेंसर से आपको अभी कोई मतलब नहीं होना चाहिए, पूरे एडवांस में आपको कहीं नहीं पूछेगा, ठीक है? टेंसर वगैरह का, ठीक है? ठीक है, चलो नेक्स्ट क्वेश्चन पे चलते हैं। प्लीज सॉल्व दिस क्वेश्चन। स्केलर को प्रायोरिटी देनी है अपने सिलेबस के अकॉर्डिंग, जो ये जेई एडवांस में है। प्लीज़ एक बार जेई एडवांस का सिलेबस जाके देखिए, उसमें टेंसर वगैरह का कहीं कोई नाम नहीं है। स्केलर और वेक्टर क्वांटिटी अपने में भी ओनली स्केलर को अपन को प्रायोरिटी देनी है अभी, ठीक है? वो अभी बैचलर्स का है, जो आप टेंसर वगैरह बोल रहे हैं वो आप बैचलर्स में देखेंगे अभी, यहाँ पर उसका कोई मतलब नहीं है। स्केलर अगर आपके में ऑप्शन है तो स्केलर, वैसे तो आएगा नहीं एडवांस में, आप स्केलर ही उसको, ठीक है? स्केलर लेके चलिए। अरे आपके सिलेबस में अभी देखो, अभी जिस लेवल पे आप उस लेवल पे देखो ना। आपको टेंसर के बारे में कुछ पता है? जो आप टेंसर टेंसर बोल रहे हो, आपको कुछ पता है? सिर्फ याद कर लेने से सब हो जाएगा क्या? आपको पता है स्केलर के बारे में, तो आप स्केलर लिखो ना। क्यों आप उस टेंसर के पीछे भाग रहे हो? पूरा पी वाई क्यूज, आपने एडवांस के इतने सारे पी वाई क्यूज देखे, उसमें एक भी था कहीं टेंसर? कि आपने किसी से बोला हो कि आप एडवांस के क्वेश्चन में आपने टेंसर पे क्वेश्चन देखे हो, कि आपसे बना नहीं कोई टेंसर का क्वेश्चन? स्केलर पर फोकस करो ना यार, जो अपने सिलेबस में है, उस पर फोकस करो। अरे अरे, हाँ डाउट तो ज़रूर पूछो ना यार। मैं वही बता रहा हूँ कि आपके सिलेबस में नहीं है टेंशन, ठीक है? तो उस पर इतना फोकस करने की ज़रूरत नहीं है, ठीक है? नाउ मूव टू दिस क्वेश्चन, ठीक है? इस क्वेश्चन को करते हैं अभी। नाउ मूव टू दिस क्वेश्चन। Which one of the following option represent the magnetic field B cap at O due to the current flowing in the direction wire segment laying on the XY plane, right? अभी इस क्वेश्चन पे फोकस कीजिए, ठीक है? वो मैं अलग से क्लास लूँगा, उसमें देखेंगे। आप शायद लास्ट क्लास में थे नहीं, ये पी वाई क्यूज़ का सेक्शन चल रहा है अभी, ठीक है? इसमें अभी ड्राइव नहीं कर सकता मैं। उसके लिए अगर आपको चाहिए तो एक एक्स्ट्रा क्लास रख लेंगे, ठीक है? ओके, सो which one of the following option represent the magnetic field B cap at O due to the current flowing in the given wire segment laying on the XY plane? Okay, so this is our wire connection. Okay, here is a semi-infinite wire, right? Okay, it's not a semi-infinite wire, right? Okay, laying in the XY plane. Okay, so first we find out that if I name these points, that is A, B, C, D, E, and suppose I write F here, right? And this as A dash, I think मैंने कुछ लिख नहीं पाया तो A dash लिख देते हैं। ओके, तो देखो, ए बी और ओ सी, दैट इज मैग्नेटिक फील्ड ड्यू टू बी ड्यू टू ए बी कॉमा ओ सी कॉमा ई एफ से, तो जो अपना मैग्नेटिक फील्ड होगा वो ज़ीरो होगा। ओके, ये समझ में आया? ये समझ में आया कि नहीं? इनकी वजह से तो मैग्नेटिक फील्ड जीरो होगा, इसकी वजह से, इसकी वजह से और इसकी वजह से, राइट? व्हाट वी हैव टू कैलकुलेट अबाउट that is our due to BC and EO and A dash A, that is V due to A dash A plus B due to BC plus B due to EC, right? Sorry, EO. A, B, C, D. Oh, sorry, this is D, right? Sorry, this one is D. Okay, इसकी वजह से अपना आएगा V net, right? एट पॉइंट ओ पे निकालना है ना, तो चलो सॉल्व करते हैं इसको. This one is LV2 and this one is LV2, right? This one is so. If I connect this point to this O, so what is this angle? That is 45, I think, right? As this one is L and this one is also L, so it is an isosceles triangle, right angle triangle, right? So this is 45 and this also 45 degree. Okay, and this is a quarter and this is the semicircle. So first we find the magnetic field due to this wire, that is equal to mu naught I upon 4 pi r, that is distance from the wire, that is equal to L, I think. Okay, so we gonna find BA dash, right? That is equal to mu naught I upon 4 pi r into sine 0, that is this one angle here, this angle. Okay, this one angle, one is 0 and another one is sine 45 degree. To understand how I calculate this angle made by the point on the two ends of the wire, right? One is 0 degree and other one is 45 degree, right? This one is 45 degree and this one is 0 degree. From here we get mu naught I upon 4 pi L into 1 upon root 2. So it is B due to A into A dash, right? Now we find the B due to BC, the loop. Okay, semicircular loop, that is due to mu naught I upon 4R, or that is 2R into theta by 360. If you go through the basic formula, it is B due to BC is equal to हो जाएगा mu naught I upon 2R into 1v2, as the theta is 180 degree here, right? And what is R? That is LV2 from here. Let me write on the next page. B due to BC is equal to हो जाएगा अपना, that is equal to mu naught I upon 4R, and here R is equal to mu naught I upon 4, that is R is equal to LV2. Okay, LV2, that is here equal to mu naught I upon 2R, 2L, right? And now B due to that quarter part, right? That is equal to of radius LV4. Okay, and the radius is in the direction of, sorry, radius is LV4, LV4, that is D, sorry, that is due to DC is equal to mu naught I upon 2R into mu naught I upon 90 degree upon 360 degree, right? So from here we get mu naught I upon 8R. Okay, that is equal to mu naught I upon 8 times of, that is R is equal to LV4, I think. Okay, यहाँ पर रेडियस कितना है अपना, LV4 है ना, that is LV4, right? So we put LV4, from here we get mu naught I upon 2 times of L. So as the direction of the current is in the same direction, so the direction of magnetic field is also same. It is in the cross direction, so we can directly add all the magnetic fields, right? इन सबको डायरेक्टली ऐड कर सकते हैं. दैट इज म्यू नॉट आई अपॉन 2l प्लस म्यू नॉट आई अपॉन 2l प्लस what is the last one, that is equal to mu naught I upon, that is mu naught I upon 4 root 2 times of pi l. Okay, mu naught I upon 4 pi, that is l into 1 upon root 2. From here we get our mu naught I l. If I take it out, okay, on what we get, mu naught I l 1 upon 4 pi root 2, 4 root 2 times of pi, right? Now what is the answer? What is our answer? Mu naught I in the minus kf. Okay, so it is kf and the direction of is negative kf. Okay, so direction is negative kf in the, okay, mu naught I upon, okay, so c is our answer, right? Do you understand this? ओके, आज के लिए इतना ही रखते हैं, वैसे भी नोट्स पूरे हो चुके हैं अपने. ठीक है, और कोई डाउट हो तो बताओ इसमें क्वेश्चन में. टू अंडरस्टैंड दिस, आज के लिए इतना ही रखते हैं. ये वाला अपना हो गया. अगली बार किसी नेक्स्ट चैप्टर के पीवाईक्यूज देखेंगे. ठीक है, आज के लिए इतना ही रखते हैं. ओके, बेस्ट ऑफ लक, और अच्छे से तैयारी करो, सब अच्छे से पढ़ाई करो. ठीक है, और कोई डाउट हो तो बताओ. प्रशांत कुमार, कोई डाउट है प्रशांत? कोई डाउट हो तो बताओ. इफ़ यू हैव एनी डाउट प्लीज़ टेल मी. ठीक है, चलो आज के लिए इतना ही है, कोई डाउट नहीं है. ठीक है.